Hello everyone, this is Bradley Sward, and in this video today we're going to take a look at other coding problems that the world has for us to solve. It's not just advent of code like I've been doing for the middle of December, which is, it's moving on a month from there already. So it's like, well, what other things are available? And I just happened across on the Advent of Code subreddit. They mentioned this 538, these puzzles that are solvable, and it's pretty cool because there's like 300 something riddles. It's like, oh my god! So here is the problem, at least the first part of the problem, brought to us by a man named Richard Jacobson. And it's saying you are at the gym with your friends and you're playing basketball and you're shooting hoops and you've got, basically you've got your 2-point baskets and your 3-point baskets. Just normal everyday thing. No free throws here according to this. And the question is basically, if I wanted to score 8 points, well, how many different ways are there for me to score those 8 points? And so you can look here and you say, well, there's 2 ways according to this example. You could shoot 4 2-pointers, 4 layups or whatnot, or you can hit 2 threes, and then what's left over is a 2-point shot. And so, the key here is that it says the order of the shots does not matter, and that actually simplifies things pretty greatly because it could get a little more complicated, but with recursion and whatnot, if the order of the shots did matter, because like in this case, it says that you could shoot 2 3-pointers and 1 2-pointer. Well, it doesn't, again, with the order matters if it matters, and it doesn't, because it'd be like I could shoot a 3, then a 2, then a 3, or I could shoot a 2, then a 3, then a 3. Or then I could shoot a 2, then a 3, and a 3. So there looks like there's 3 different ways that thing, or where does the 2-pointer go inside of those 3 combinations? And so that would be more than the 2 combinations you see. So the question came up like, oh my goodness, how would I solve this for 60? If I wanted to score 60 points, how many different ways are there to do this? And you go, well, it sounds pretty complicated. And when you think things out, at first you're like, you come up with some outlandish algorithms to try to solve this problem, but then you can reduce this down pretty greatly using linear algebra, which I'll just show you here, right? So here is a mathematical formula that we can use to, basically convey this information. So if I have the number of 2-point baskets and I represent that as X, and the number of 3-point baskets is represented by Y, and C is the end score that we want to achieve, well, you would have some kind of formula like this. 2x plus 3y equals C, because these are the number of 2-point baskets, and these are the number of 3-point baskets, and then the total points. So we remember, or from previous here, it said like if I wanted C to be 8, then there were 2 combinations of ways to make this work. And I'm not going to go into making a spreadsheet for this, but because I already have some code written in C++ that I'm going to show you guys. But I can say, well, if I want 8 points, and I'll just put the 8 here, and you say, okay, well, basically this is, exclusive. If you don't score 2-pointers to get there, then you have to have some combination of 3-pointers and so forth, and vice versa. So the question is, like with this, the algorithm that I'm going to put forward here is basically saying, well, how many 3-point baskets can I use to make 8? And then work my way down from that number down to 0, and then just basically ask on a case-by-case basis, well, in this case, if there's 2 3s, well, how many 2s would there be? And then when I find that number, I go, well, would that number actually get me to the score that I want? Or because of the way the evenness and the oddness of adding these numbers together come out, does that get me a value that isn't the value I'm looking for? And in that case, then it's not possible to have that combination of x's and y's. So just to say here, okay, so I'm going to use the y values. And I'm using the y values here because very specifically that when you do this, if you do this by 3s, it's 50% more efficient to do this by 3s than it is to do this by 2s. So I say, okay, if I take my 8 value and I divide it by 3, and I basically use integer math here, the y value that I would have to start with is 2, because I can't start with 3 3-pointers, because then that would be 9, which would be more than the 8 that I'm looking for already. So there has to be 2 3-point baskets, and then there could be 1, and then there could be 0. We don't know the answers just yet. So I'm going to start from basically the floor function of C divided by 3, and work my way down to 0, and just check to see, using these formulas, if I just kind of reduce this down and say, okay, now what is the x value? C minus 3y, basically divided by 2 will get me my x. Oops. And that's kind of what I'm going for here. X equals C, divided by 2. And this result, basically this is where the modulus effect comes in here. This result has to be an integer value when you get done with this, otherwise it's not possible for you to do what you're trying to accomplish here. So if C is 8, let me just fill in, if C is 8, in this case, C is 8, and then the y values are modified. So if the y value is 2, well, this is 8 minus 6 is 2. 2 divided by 2 is full 1. So yep, that will work. And we discussed that there's two 3-pointers and one 2-pointer to get me to 8. And so now if this is 1, 8 minus 3 is equal to 5. 5 divided by 2 is 2.5. I can't make half of a 3-point basket, so this is not something that I can work with. And so then to finish up here, if y is 0, then this becomes an 8 divided by 2, 4, full on 4. And there you go, lo and behold, using this kind of algorithm, working our way down, we figured out that the solution for C equals 8, or N equals 8, I guess in this case, would be 2. So now let's just kind of see what we can do. Let's bang out some C++ code to make this thing work, so we can make this algorithmic, and we can try this for any number. Okay, I did neglect to describe the actual problem that we're trying to solve at some point along here. So we're going to say we're going to figure out how many ways there are to make 60 points. We're going to say there's X ways to do that. And then what we're going to do is try to find a value for this N, number of points that's larger than 60, that has a number of ways to make that value that's less than the number of ways to make the 60, which was the X, which I just talked about a couple seconds ago. So it's kind of complicated. Just I think me talking it out is more complicated than just reading it and getting a feel for it. And the answer, I feel, is probably pretty intuitive. And the reason for that the answer is pretty intuitive is that there's only 2 ways to make a basket, or make baskets. And so if you can't make a basket one way, you have to make it the other in order to fulfill the number of points. So it reduces down the number of choices that you have when you're trying to solve the problem. So I've already written some code that kind of handles the runner of this thing. So I'm going to figure out the number of ways I can get to 60 and print that out just so I can see it on the screen. And then for values from 61 on up, I'm just going to go, and I can figure out exactly what the max value is for this. But just to say, I'm going to try from 61 all the way up to 20,000, and just to say, oh, okay, how many ways can you get to that number? And then if it's less than the number of ways we can get to 60, let's print that thing out. So the question then comes up to, like, what is the algorithm in place here? So I want to make sure, how many different ways are there? Well, you start with 0, and I want to return at the end of the day that number, whatever that may be. And then from there I go, well, again, I'm going to keep track of the number of 3-point baskets. And so I'm going to use a for loop here, because again, if I take whatever value and I divide it by 3, that's the maximum number of 3-point baskets I could make. And then as I reduce that number down, and I reduce it down to 0, that will then tell me at the end of the day how many maximum 2-point baskets there are. So I will try every possible value from maximum 3-point baskets to minimum 3-point baskets. And at the end of the day, however values come up will be the way that we get the answer. So I say, okay, so I'm going to call them 3s. The number of 3-point baskets is equal to my N value divided by 3. Because I'm going to divide, and it's going to be integer division. So if it's like, if it's a number larger than something, then it's not going to go through. And I'm going to go, okay, while my 3's values are greater than or equal to 0, and I'm going to reduce this down by 1, minus 3's. And I could work my way backwards or forwards or up or down, but I just think that this will work for us. And I say, okay, now if, and we talked about this, and I go, okay, take my N value, and I subtract off 3 times the number of 3's. Make sure I'm, yep, okay. So I just want to make sure I get all the parentheses how I need them to be, and I'll fix everything up here in a second. Okay, if I take that value and I divide it by 2, and that'll tell me how many 2-point baskets I have to fulfill the value and make sure that I get to the N value. But again, I have to make sure that the value is even at the end of the day. So I'm just going to do, I could do a mod 2, but I'm going to do an AND 1. And that will basically do the same thing, and it'll be faster than a modulus operation. And I can say, well, if this thing is equal to 0, then I'm going to increment my total. And let's just see at the end of the day what we get out of this thing. Did I get the correct answer? And I do. And so, or at least the answer that I feel that is the answer to this. So I say, okay, there are 11 ways to make it to 60 points. And again, the number of ways, or the ways we do it really isn't that important. But there are 10 ways to get to 61 points following these rules. Because we're reducing, we're starting from, if this is 60, excuse me, we're starting from 23 pointers. And then we're just going to keep going down 20 to 19 to 18 to 17 to 16 to 15 because it's a linear combination. There's only one answer for x for every y value that we find, and then when we get down to 0 3-pointers, well then there have to be 32s, right? Because you have to get 32-point shots to get to 60. So it tries every combination of there, and as it turns out, only 11 of those, or 10 of those, or 11 of those for the 60, but only 10 of them for 61. So that is the solution here for the first problem. And so now we can kind of move on to see problem 2, the second part that is similar, but slightly different than what you see here. So here's the second problem in the chain here. It's a little different problem, so it's not the same problem, just part 2, like an advent of code thing. But it says that you have 100 days to arm yourself. Aliens are coming, and they're going to basically destroy the Earth, and you have to be ready with everything you've got to fight back. So the question is, how many space fighters can you produce in 100 days? And the rule is you start with one constructor, one assembler, that can create ships at 1 per hour. But the thing is, you can actually use the assembler to create another assembler, but that one, instead of taking 1 hour, takes 6 days, which is 144 hours. So you have 2,400 hours to get ready. You got 144 days to make an assembler, and then you also can make a new ship in 1 hour. And the question is, well, how do you maximize this so you can produce the most assemblers, which then can produce the most warships? And I think we can do this without writing any code whatsoever. Okay, so when I first started thinking about this, and I go, well, what if I didn't do anything more than produce ships? I have myself an assembler. I have 2,400 hours in order to do the work. And so if I do that exactly as I think about it, I end up with 2,400 ships, and that sounds pretty good. I don't know. I don't think it says what they're coming with, but again, the goal is we got to make sure we're the best prepared for anything like that. So you're like, well, what if I immediately doubled my assemblers? So take this and multiply it by 2, and remember, it takes 6 days for this to occur. So I can just say, okay, take this and subtract off 144 hours, and then take this, and then there you go. You get 4,512 ships if you immediately double the assembler, and then you use the rest of the time to do the job. And you're like, well, let's take this to the natural conclusion and work our way all the way through. And you can see that there is a limit here, a high limit, where I work my way down here. I believe this is my answer. I'm not 100% sure on this at the moment because it doesn't tell you if you're right, and they will give your answers later on in the next week. But at the moment, I think this is pretty good to go because any ship you produce at any time prior to the maximum time, the maximum time where you can go and produce the most ships is just wasted time. So like if I produced 50 up front and then just kept going, well, yeah, I produced 50 ships, but here, those 50 time units could have made 50 times 32,768 different ships because of the way that it matters that much more, double, everything just doubles as quickly as possible. So I do believe, I'm fairly confident that this is the solution to the problem. And if I'm wrong, I will find out soon enough. And so that is pretty much how I solved these 2 problems. Pretty interesting problems. I look forward to the next week. The nice part is there's tons of riddles and problems to go back on and to solve. And it's great that it appears that at least every week or 2, they're going to be putting out new problems on this. So for those of you who have that itch like I do, to solve some problems and not just go back and do old advent of code problems, this is a great idea. And I hope you guys will follow along and come up with your own solutions as well. So as always, thanks for sticking it out with me with these videos. I look forward to talking to you guys again sometime with some other problems and some other programming related nonsense. So have a great day, everybody. Take care, and I'll see you then.